Let's take a look at some series circuit practice. So what I have right here is I'm going to have 3 resistors in series, and the source is going to be 24 volts DC. So what I'm going to do is I'm going to start by drawing the circuit right here, okay? So I'm going to put a voltage source over here at 24 VDC, and then I'm going to go ahead and I'm going to put 3 resistors, and I'm going to put them in series like this. There's a little bit of room between them, okay? So my first R1 right here is 1,000 ohms. My second one right here is 4,700 ohms, and my other one right here is 5,600 ohms. Okay, those are my 3 resistors. Now, these are in series, so we know that in series, the R total is equal to R1 plus R2 plus R3. That's how that works. So if I take those and I get R total equal to 1,000 ohms plus 4,700 ohms plus 5,600 ohms, that's going to give me my total resistance here. So I come to my calculator right here and I go 1,000, let's see if you guys can see that on there or not, plus 4,700 plus 5,600 equals 11,300 ohms is what that's coming up with. Okay, so now if I go ahead and draw this circuit that's simplified, I would put my 24 VDC over here again, and I would make an R total right here, a single resistor, R total of equal to 11,300 ohms. So if you put 11,300 ohms against a 24 VDC voltage source, it's going to generate current. All right, you're going to get current I flowing through here, and that is going to be determined by I is equal to V over R. Okay, so my voltage is 24 VDC, and my resistance is 11,300 ohms. So I come here and I divide 24 divided by 11,300. I get 0.00212 amps. So that is my current that's going to flow. And this current is going to flow through this circuit here, which is a depiction or a simplified version of this circuit. So that means that 0.00212 amps flows out of the voltage source and goes through this resistor, and this resistor, and this resistor. They're all the same because there's only one path. There's nowhere else for the current to flow other than through each load. So this is going to be 0.00212 amps. This is going to be 0.00212 amps. And this is going to be 0.00212 amps. Okay. Now, what we can do is we can get the voltage drop through each one of these. All right. So we modify our formula here using our power wheel for Ohm's law and move the R over here. We get voltage is equal to current times resistance. So we take a look at the first one here, 0.00212 amps. That's my current times the resistance times 1,000 ohms. My second resistor here, the current is the same. Current stays the same, 212 amps times 4,700 ohms. And the last one here, I is the same, 0.00212 amps times 5,600 ohms. Okay, and so we go and we come here and we take a look at those. We got 0.00212 times 1,000. We're going to end up with 2.12 volts. Okay, so I come right here. This is dropping 2.12 volts. Let's do the next one real quick before we see if it's looking right. 0.00212 times 4,700. We get 9.964 volts. Okay, 9.964 volts. So, just as a side note, we noticed that this resistor is 1,000, and that's 4,700. So it's almost 5 times larger, this one here. So if we look at the voltage drop through each one, we got 2 and almost 10. So that's close to 5 times the voltage drop. So it seems like these numbers are making sense. It seems like they're working out like they should. Okay, let's keep going on this last one. We got 0.00212 times 5600, and we get 11.872 volts. 11.872 volts right here. Okay, and that would be the voltage drop through each one. Now, we got the resistance, the current, and the voltage drop through each one of these. Now, the last thing that we can do to check is to be sure that the total voltage drop for each of these is equal to the source, all right? So we have 24 volt source, so my V total should be equal to this one here, 2.12 volts, plus the second voltage drop, 9.964 volts, plus the last one, 11.872 volts. And let's see what that all equals, all right? So if I come right here and I clear it, and I go ahead and put in 2.12 plus 9.964 plus 11.872, I get pretty close, 23.95 or 96, 23.956 volts, which is very close to here. I've got a little bit of rounding error going on here, is why it didn't exactly equal it, but that's pretty close, okay? And so that tells me that the voltage drops add up, and that is just our series circuit practice.